Hey guys, today we want to identify rational and irrational numbers. So let's get started. First we want to do is we want to review. We want to review the different groups of numbers that we learned so far that are in that song. So the first group that we looked at was natural numbers, numbers that came about naturally. And this group starts at 1, and it goes from 1 to 2 to 3 and so on, and keeps on going from there. The next group is the whole numbers, and they added 0 to this group of numbers, and they call that the whole numbers. And then the next group are integers, and the integers are added when they add the negative numbers with 0, 1, 2, 3, and so on. If you look, it just keeps on going in a positive way, and it keeps on going in a negative way. So there are 3 groups of numbers. So looking at that group, you say, well, where are the fractions and the decimals? Well, the fraction and decimals are in the next group that we're going to look at, and that is called the rational numbers. So we want to look at and say, okay, what is a rational number? Well, let's start with the definition, and you want to write this down. The rational number is a number that can be written as a fraction of 2 integers, a and b, where b cannot be 0. So if you want to look the bottom of the fraction, that cannot be 0. So b cannot equal 0. Well, there's a clue here. When you look at the word rational, you want to look and understand that the first few letters of rational is the word ratio. So what you can really think about is, to help you remember what a rational number is, it's a ratio of 2 integers. So that's a clue to help figure out what you need to when you're trying to remember what a rational number is. Alright, let's look at some integers here. I got a group of integers, and I want to set up some fractions here and look, okay, what is a rational number and what do they include? What type of numbers do they include? So the first one we want to look at is an easy one. I want to look at the fraction of 2, but what do I put on the bottom? Well, you know, if you have a whole number, you can always put 1 in the denominator to make it 2 over 1. Well, so all these whole numbers I can write as a fraction, and that is equal to 2. So 2 is a rational number. So in our list, all integers are rational numbers. All right, let's look at the next one. Let's look at a negative number. Negative 1 on the top, that's my a, and 4, that's an integer, that's my b, and that doesn't equal 0, so I'm good. Now look, what do you have? I have a fraction, just what you have in the definition. So a fraction is also a rational number because it follows the definition. Let's take a second and let's go over to the calc here, and let's divide that. And let's kick it to a decimal to see what kind of decimal that is. Well, if you look, a fourth, negative 1/4, is negative 0.25. So if you look, that's called a terminating decimal. Terminating means stop. They called Arnold Schwarzenegger the Terminator because you stopped your life. So this number, when it stops at 5.25, that's called a terminating decimal. That is a rational number. So now I have another one. So all the terminating decimals are also rational numbers. All right, let's look at another one. Let's look at negative 2/3. Now, again, it's a fraction which follows right along, but let's look at the decimal of negative 2/3. So if I take negative 2, clear that off, if I take 2 divided by 3, I'm going to get 0.6666, and as you know, that's 6 repeating. So what we're going to do is we're going to move that over here, try to get it all in there. There's an easier way to write that. It's 0.6 with the repeating bar above the 6. So if you look, this doesn't stop, but it repeats, and I can write a fraction for it. So repeating decimals are also rational numbers. They're a ratio of two integers. All right, next one. Let's look at improper. What happens when I get negative 10 over 4? Now, this is improper, so I'm going to divide it and take 10 divided by 4, and let's look at the decimal, 2.5. So now that's a terminating decimal. So that is a rational number. And mixed numbers, this is also 2 and 1/2. Mixed numbers are also rational numbers. Now we got one left down here. What is it? Well, it's a specific number. It's actually a square root. When we looked at square roots in an earlier lesson, what is the square root of 25? Well, 25 is a perfect square. And so what are the roots? What multiplies times itself to get 25? Well, that's 5. And 5 is a rational number. So if I have the square root of a perfect square, that is going to give me a rational number because it's going to work out to a nice number. All right, so we got all of these this list of what's irrational number. Let's go on. What's irrational? What numbers are included in irrational numbers? Well, the first thing we want to look at is we want to look at the square root of 2. Now, some kids think the square root of 2 is 1 because 1 plus 1 is 2, but it has to be 1 times 1, which is 1. So what number times itself is 2? Is 2 a perfect square? No, it's not. It's actually 1 point, look at my notes here, 41421 and ... It keeps on going. It doesn't stop. It doesn't repeat. It doesn't terminate. It keeps on going. So the little ... gets added to show that it's going to keep on going. That is an irrational number. I can't make a fraction for that number. There's no way, because it continues to go on. Oh, let's try one more. Let's try the square root of 80. Now, is 80 a perfect square? Is there two numbers that multiply to give you 80? Well, no, it's close. 81, that's 9, so it should almost be 9. So if you look, it's going to be 8.94427. So ... It doesn't stop. It's going to continue. It's going to continue to go on. It's not going to terminate. This decimal is not going to repeat. It's going to continue on going. And I can't write a fraction for that. So let's look at what we got here. Here's our list. Non-repeating decimals. Okay? Non-repeatings are irrational. Non-terminating decimals that don't stop. They keep on going. And the square roots of non-perfect squares. These are non-perfect squares. They will give me the non-terminating decimals that keep on going. Those are called irrational numbers. Another way to think about it, on this picture here, can you go to the store or go get a haircut and they ask you, can I have square root of $2? Does that make sense? No. So this really doesn't work out well. This is an irrational number. All right, let's wrap this up. Wrap up. Let's look at the definition one more time. If you haven't written it down, make sure you write it down. Rational numbers is a number that can be written as a fraction, a over b, where a is an integer and b is an integer. But b cannot be 0 in the bottom of the fraction. So what does this include? Well, it includes whole numbers, fractions, mixed numbers, terminating decimals, decimals that stop, repeating decimals, because I can write a fraction for that, and square roots of perfect squares, like the square root of 4, square root of 9. Those work out nice. So what's an irrational number? Well, an irrational number cannot be written as a fraction. And this includes decimals that they keep on going, dot, dot, dot. One of the most famous ones is pi, 3.141529, dot, dot. It just keeps on going. Pi is probably the most famous irrational number. There's no fraction for pi. And you probably ask, well, what about 22 sevenths? I see 22 sevenths. Well, 22 sevenths is approximation for pi, because I really can't write a fraction for it. And what's the other irrational? Well, it's the square root of non-perfect squares. So the square root of 7, square root of 11, those are all going to be irrational numbers, because if I do the square root of 11, it's going to continue to go on and on and on. So hopefully you can identify rational and irrational numbers from this video. Thanks.